Thank you for coming. This session is on virtualizing Active Directory the right way. My name is Deji Akomolafe. I'm a staff solutions architect at VMware. It's a fancy title for this is the guy who talks to customer. I talk to customers on a daily basis and help them understand how to best architect the infrastructure for Microsoft applications on vSphere.
How's everybody doing? My name is Matt Leibowitz. I lead the virtualization discipline for EMC's professional services. Hope everyone's having a good conference. Anybody feel like thumb wrestling?
All right, we're going to get started, and before we do, I have to show you this. I am compelled to show you this by people you know. I am not going to tell you anything. We are not going to tell you anything forward-looking, any secret, nothing in this session. But as you know, we have to show you this. It's a disclaimer, standard, and we've done our job. All right, today we are going to be taking you through what you already know, and then we are going to complement that with what we think you should know to help you better understand how to virtualize Active Directory. We'll go quickly through Active Directory overview. We will answer the question of why do you or should you virtualize Active Directory. We will highlight some of the common objections to virtualizing Active Directory. We will talk about consideration and understanding domain controller virtualization generally. Then we'll segue into the recommended practices for virtualizing Active Directory. We'll talk about the new features in Windows that enhances your ability to safely virtualize domain controllers. And why we'll do that is to address the common objections and let you know how these new features help you overcome those objections. We will do a real quick intro to some of the features that we described in step 6. We'll talk about the DC safety consideration, and then we'll talk about an event, a site failure event, and how the new features can help you overcome those. We will talk about protecting Active Directory with SRM, just a little conceptual overview, a use case for using SRM to complement the availability and safety of your domain infrastructure. This session is not going to be an AD class. We do understand that you are here. The fact that you are here means that you run AD, or you're planning to. There will be experts, or there are experts in this room in the realm of Active Directory virtual infrastructure. What we will talk about here is a real overview, high-level overview of Active Directory functionalities and how it works, how they relate together, and then we will roll those into why people fear virtualizing domain controllers, and we will help you answer the question of how you can overcome those objections. Real quickly, as we all know, in an Active Directory infrastructure, you have multiple domain controllers, and a write can originate from any domain controller. Basic. For example, you have 5 domain controllers. If they are all writable domain controllers, you can create a user, modify an object in Active Directory on any of the domain controllers, except maybe for the RODC, which is a special case. The schema update, of course, we know that's where schema update always happens. So those we would say are special. When write or change originates from any domain controllers, those domain controllers need to replicate it to their partners so that everybody is in sync within that forest or the domain. Selective replication is what domain controllers use. They pick selective partners and they replicate their transactions to those partners. Those partners then help spread it out. Again, AD 101, we're not teaching anything really detailed here. When changes happen on a DC, those changes will replicate eventually. Your objective is to make them replicate as soon as possible. Optimal replication is a requirement in an Active Directory infrastructure. We will get into cases where when that doesn't happen, you will see problems in AD. preferably on time, but we want them to replicate eventually. There's an additional complexity when you have multi-domain infrastructure. Of course, you know about not mixing the infrastructure master and the global catalog and how those can complicate your replication. Also, we can't mention replication and Active Directory infrastructure and not tell you about the common tools for diagnosing any replication issues, because that's usually one of the big problems in an Active Directory infrastructure. So we mentioned briefly the Active Directory replication status tools that let you see at a glance your replication status. So replication, convergence, and selective partnership, how do they do that? Let's take a quick look at how Active Directory objects are replicated, or how a DC determines that it has an object to replicate to other domain controllers. The Directory Service Agent, the GUID, you call it the DSA GUID, is unique across the forest. It's unique to a domain controller. No two domain controllers will have the same DSA GUID in a forest or in a domain. It's persistent over the life of that domain controller. It's used in the update sequence number to track the DC's originating updates. So a DC will always have a DSA GUID. The DSA GUID will always be persistent over the life of that domain controller. That DC uses the DSA GUID to track changes that it originates. The invocation ID is used by the DSA to identify that domain controller's copy of the Active Directory database. The Active Directory database is shared among all the domain controllers. Each of the domain controllers has its own invocation ID used by the DSA to track its own copy. The invocation ID can change over time, and we will see examples of that changing in subsequent slide. Then you have the update sequence number, the USN, also known as the logical clock. This is used by the DSA to track updates that it sends or received from other domain controllers. This increases per every write transaction. Every update, every creation of new objects will increment the USN. The USN is globally unique within a forest. You will not have two objects or two write operations or two change operations having the same USN. Now, if you put all these three things together, the DSA GUID, the USN, the invocation ID, you put them together, and a DC would then determine that it has objects to replicate. It's made change to an object, increment the USN. It has its own invocation ID, uses that to replicate that change to another domain controller. This is a common question. What about timestamp? If you make simultaneous changes to one object in an Active Directory infrastructure, it is possible for two admins to make changes to one object. Now, we talked about the USN and the invocation ID. Another thing that can be used in determining the latest write or the winner of those write operations or the sequence of the update is the timestamp. It's not exclusively used in AD. However, the stamp, when you combine the version of the object with the originating time and the originating DSA, there will be uniqueness. The uniqueness is what determines the replicable object, and that's what the DC sends to its partners. We will get into more details around this in subsequent slide.
Okay, so now we're going to talk about why you would want to virtualize Active Directory. And we're going to go through this somewhat quickly. We had this session on Monday, and we ran out of time, so we're going to skip through some of these slides a little quickly. They will be available online. If you happen to be here from the Monday session, the bad news is the jokes are all the same. So, except that one was new. Okay, so virtualization has become mainstream, right? Just quick show of hands. How many people in this room still think virtualization is just for development and test? No one, okay. A lot of organizations have a virtualized first policy, so this has become the new standard. Active Directory virtualization is fully supported. Microsoft has something called the Server Virtualization Validation Program, which essentially validates their operating systems and their applications against hypervisors. And as long as you use the correct version of vSphere, correct version of Windows, you're fully supported. Active Directory, despite being critical in an environment, critical in its importance for uptime, it's actually a relatively virtualization-friendly workload. It doesn't have high I/O demands. It's a distributed model like we spoke about, so we're not dependent on one really big, important server. We can distribute the load. And then its utilization characteristics are relatively low. They're interchangeable, like we said. They can, any domain controller can essentially function for another. And then physical domain controllers will waste money and resources. Modern servers today, 16 to 20 cores, 64, 128 gigs of RAM. That's going to be a lot more than a domain controller is going to use, even for a large domain. So it's unlikely you're going to use all those resources unless you virtualize. So let's look at some of the common objections that we've heard, over the years. The fear of the stolen VMDK. This is the fear that someone can get access to either your storage or the ESXi host itself, take that VMDK, and now they've got access to your domain database and they can do all sorts of bad things. The reality is it's no more likely to happen than someone stealing a backup tape. I'd argue that is more likely. And you've got other methods to protect against that, encryption at various levels. Privilege escalation. I've seen this one many, many times. People think if I'm going to be a vCenter admin, I also have to be a domain admin. There's no reason to do that. Both systems have their own role-based access controls. You should use them to delineate who gets access to which systems. This one I think I've heard more than any. I have to keep one domain controller physical, right? I don't want to have a chicken or the egg scenario. I got to keep that one server physical. I want to make sure my operations master server, one that holds that FSMO role, has to stay physical. The reality is it's easy enough to transfer or even seize that role if the server's down and you can't get it back up. So I wouldn't use that as an objection to virtualizing your domain controllers. And then finally, deviates from a standard process or a standard build. And I think we all know in this room, virtualization improves that standardization. We've got our templates that are customized just for our organization. We deploy all servers from those templates, and we have standardization.
Okay. Let's now quickly jump into best practices or recommended practices. And the best practices or the common practices for virtualizing domain controllers do not really differ from what you would do if those domain controllers are physical. Deploy multiple domain controllers across multiple sites so you don't have a single site failure that impacts your entire infrastructure. That's a no-brainer. It's the same thing you would do in the physical world. Distribute the operation master's role. The first DC, as you know, always has all the operation master roles, which we call the FSMO roles. If you leave that as is, what happens is that domain controller performs all the FSMO role operation. It will get bogged down, and you also have that single point of failure with all the roles being down if one domain controller goes down. It's, again, best practices. It's not unique to virtualization. Use effective role-based access control. Like my colleague just mentioned, a vSphere administrator does not require a domain admin privilege. The inverse is also true. A domain admin does not require vSphere admin privilege to manage or to interact with the domain controller. So the two do not depend on each other, and there is no requirement for you to not use role-based access to separate and segregate responsibilities. Enforce well-defined admin practices. This, again, doesn't depend on whether or not you're virtualizing. It's the same thing you would do as if it were physical. There is this common question of should we P2V, physical to virtual process, P2V a domain controller or not to P2V a domain controller. P2Ving a domain controller or any workload eases the migration process because it goes by very quickly. But for domain controller especially, they are easily disposable, and they are easy to stand up. Create a VM, run DC promo. This VM is a domain controller within a 30 minutes time span. There is no logical reason to P2V a domain controller. And as Mike just mentioned, you can easily transfer or seize a role, so there is no logical reason to P2V. We recommend in the virtual infrastructure that you leverage the availability and the resilience built into vSphere, which is not available in the physical world. So these are special considerations. Use vSphere HA. It helps you improve availability of a domain controller. If an ESX host goes down, we can quickly restart the VM on that ESX host, and your DC comes up really faster than it would be in the physical world. Use DRS rule. What you want to avoid in virtualization is when you virtualize the domain controllers, you don't want all of them landing on the same ESX host, or you don't even want multiples of them landing on the same ESX host. What you do is you use anti-affinity rule, DRS anti-affinity rule, to separate domain controllers so that they don't land on the same ESX host. Best practices, common recommendation, please use it. Use host to guest affinity so that in a disaster event, you will always know which ESX host has which domain controller. If you use host to VM affinity or guest affinity, what that does for you is let you know that ESX1 has my DC1, ESX2 has my DC2, and they will always stay there. So in a disaster event, you will know which one you want to recover first, which ESX host you want to recover first to bring up your AD infrastructure. vMotion gives you true agility. You can easily move a domain controller around if you need to service an ESX host. We ask that you use the vSphere features to complement the availability and the resilience built into AD.
Okay, so let's talk a little bit about sizing domain controllers. Sizing a domain controller is no different than sizing any other workload, right? You need to understand its requirements. Just one of the things I've seen over the years is people assume domain controllers, they don't really do anything. They just sit idle, so I don't need to give them a lot of resources. That is definitely not true, especially for larger domains. If you're not sure, if you've got a physical domain controller, you're not sure what resources it really needs, use capacity planning tools like you would any other workload. Microsoft has one, VMware has one. Both will tell you what the current utilization looks like. You know, the important point to remember is that your requirements are going to be different, so it's hard to give general guidance to say, oh, you should always give it this amount of CPU and this amount of RAM. Highly depends on your environment. But let's just talk through the different resource categories, and we'll give some general recommendations. The first is CPU, and CPU is generally easy in that domain controllers are not heavy consumers of CPU resources. And actually, your utilization will vary depending on even the use case within your own environment. The example being a smaller branch office that's just doing authentication traffic for just a few users is going to be lower utilization than one that's doing all the moves, adds, and changes in your main office. General sizing guidance, you know, this is straight from Microsoft. From 1 to 10,000 users, 1 CPU is fine. 10,000 and above, start with 2 CPUs and then scale up depending on your needs. If you're not sure and you've got a relatively large environment, start with 2 CPUs, easy to adjust on the fly if you need to. When we talk about memory, domain controllers are pretty similar to database servers in that they can cache reads from the database in memory so that subsequent reads come out of RAM. That improves performance and reduces read I/O on your disk. If you're not sure how much RAM to give the domain controller, you can take a couple different approaches. One would be just give it as much RAM as the size of the AD database under the assumption that I can just cache the entire database in RAM. That's typically not the best, unless you're trying to cache the entire database, but it's unlikely to read every single user object and everything from the database. So the best thing to do, look at this counter in Performance Monitor, database cache hit percentage. Tells you how frequently it's reading data from that cache, from the RAM. If it's not reading it frequently, increasing the RAM will increase usage of that cache, subsequently increase performance. The other thing to remember, if you've got a large forest, multi-domain, don't be surprised if your domain controller really needs 16, 32, 64 gigs. Give it what it needs, and it'll perform well. Networking, domain controllers are not really heavy consumers of network, but it's incredibly important that their networks stay up and available because they rely on replication to stay in sync. That's how they maintain that multi-master model. So give it a VMXNet3 NIC just like you would almost any other resource, any other virtual machine. You're going to get better CPU utilization, better network performance. Storage, again, this one is relatively easy. You're really sizing for capacity, not performance, and you could even improve performance further by giving it more RAM, letting it cache that database in RAM, reducing the total number of read IOs from the disk.
74% of AD-related problems is caused by DNS. It's a number from Microsoft. It is not a VMware-generated number. AD needs to be able to find objects. Clients in an AD infrastructure need to be able to resolve names, contact domain controller. Processes on domain controllers need to be able to resolve names. If they don't, bad things happen. Trademark, bad things. The consideration for name resolution, optimal name resolution, does not disappear when you virtualize your domain controllers. Virtualizing domain controllers does not amplify this problem. The same thing you would do in the physical world is what you would do with your name resolution. We are just going to stress really quickly that if your name resolution is not optimal and you are in the physical world and you've been living with that for a while, when you virtualize that infrastructure, the first thing that your users or your stakeholders are going to point to when they start experiencing a problem is because you virtualized it. Everybody will forget about the fact that you had lingering problems before you virtualized. They will blame the virtualization effort. This is why it is very critical that you get your name resolution in sync before you begin your migration effort. And if you're struggling with that in the virtual infrastructure right now, the same consideration, the same thing you would do in physical is what you would do in this virtualized infrastructure. Follow the best practices. We have a few of them here. I want to call out really quickly the initial replication conundrum that happens in an AD infrastructure, whether virtual or physical. As you know, some versions of AD require that a DC perform initial replication with a partner DC before it can start advertising itself as a domain controller. DNS services will not start on that domain controller if it's running DNS, which is usually the configuration. DNS services will not start if it's not able to perform initial synchronization with another domain controller. AD will not start. Clients will not be able to log in. Client will not be able to use that DC for their processes. If name resolution is not optimal, you will get caught with this initial sync replication conundrum. And there's a KB article here that Microsoft publishes, which tells you not to do what people do when they get into this situation. When the DC is required to sync before it can start advertising itself and it's not syncing, people go into the registry and they enable this key that says, forget about initial sync, just bring AD up anytime you boot. That creates problem for AD, and Microsoft recommends that you don't do that. So I've included the link here. Please, for your reading pleasure, you will get this presentation after VMworld. Please follow that link and get into the mindset of get DNS name resolution right before we virtualize. Let's quickly describe what happens in this scenario. Here is a DC booting up. The first thing it does is initialize its TCP/IP stack. What's my IP? Its IP is that, and then brings up its DNS client. Says, okay, my DNS in TCP/IP is configured for 10.10.10. If you notice that, this DC is pointing to itself for DNS. Okay? This DC is pointing to itself for DNS, and it says, I am instructed to first perform an initial sync before I can start advertising myself as a domain controller. So yeah, I need to sync with DC2. It's going to ask DNS client, all right, what's the IP address for DC2? DNS client is going to say, I can't answer that question because I haven't started. DNS hasn't started. The DNS server, the DNS client can answer that question. All right, okay, I need to start DNS. This is what happens. I cannot start because you haven't synced. You cannot sync because you don't know the IP address of your sync partner. All right, we don't want to get caught in that situation. This is why we highlight this. Native AD or IPAM is good. Either of the two is good. And the consideration doesn't change when you virtualize AD. What happens in a virtual infrastructure is it's easier for you to do your disaster recovery test on the vSphere infrastructure if you are using the native AD integrated DNS. It is easier than to use a physical appliance because when you're doing a DR test, you're simulating a failure without actual failure. if the DNS server, if the appliance is not at the DR site, you won't be able to get DNS running on that, in that site. If you use integrated AD integrated DNS, it comes with the domain controllers. When you recover the domain controller, the DNS is always there. So that's why, that's the only consideration when you're asking yourself, should I use the native AD DNS or should I use IPAN? For us, it doesn't really matter. It's only for that single purpose. Other consideration, to avoid the conundrum we just described, do not point your domain controller to itself as the only DNS in TCP/IP configuration. And it doesn't really matter whether it's virtualized or physical. Always distribute your DNS across multiple sites so that if you have a single site failure, you have DNS at the other site servicing our client's request. Include the loopback address in the TCP/IP configuration for that domain controller. This is the rule of thumb. Point a DC to another DC or another DNS server for primary DNS. Secondary DNS point it to somebody in a remote site. And tertiary, use the loopback address. So that if all the two other things fail, it can always rely on itself for name resolution. Include all the suffixes in your forest or use the global name, the new global name feature that was introduced in 2008 for your name resolution. This makes name resolutions easier in an AD infrastructure.
Okay, so if DNS is the most important, time sync is probably the second most important. We're going to go through this quickly in the interest of time, but the important points here, Active Directory uses proper timekeeping for conflict resolution when multiple changes are made to the database at the same time, and also for Kerberos authentication. So it's incredibly important to make sure time sync is accurate. All the stuff here, it's really just talking about how operating systems, Windows, and others keep track of time. The really important point here is that the virtual machine needs access to the CPU in order to calculate its time. And as we all know, virtual machines don't have 100% access to the CPU. They get it in proportional time slices. And what can happen when you've got a host that has more vCPUs assigned than there are physical CPUs in the host, and all those CPUs become busy, the servers can't schedule enough CPU time to schedule these timer interrupts to keep track of accurate time, and that's how you get clock drift. So it's an important point and something we've been dealing with for a long time in virtual machines. vSphere includes a timekeeping mechanism just like Windows does. Windows has a time service. vSphere has a service in the VMware tools to allow you to sync the virtual machine time with the ESXi host time. That's been there for years, and one of the things I think a lot of people don't know is that even if you disable this functionality, you uncheck that box in the VMware tools, it will still sync time with the host during certain operations, power on being the most common and most important. The other ones like snapshot, restore, you can disable, but you can't disable the one about power on. So that's an important point to remember. So the question is, what do I do? Do I rely on Windows time, or do I rely on syncing with the vSphere host or the ESXi host? Previously, the recommendation was sync with your ESXi host, disable Windows time in the guest, and manage it all through ESXi. We've had a change of heart on that one as processors have become more powerful, multi-core. Scheduling time on CPUs has become less of a problem. And vSphere has become more mature. So the recommendation now is if you've got a domain join guest, don't synchronize through the ESXi host. Don't use VMware tools. Use the regular Windows time service. Two important points. For your domain controller that holds the PDC emulator role, that's those FSMO roles we talked about earlier, sync that with an authoritative time source externally. Now, whether that's an external Stratum 1 time source on the internet or a GPS appliance or something you have inside, it's an authoritative source. Sync that ESXi host with that same source. The reason is, remember this, when I power on my virtual machine, it's going to sync my clock no matter what. So if your ESXi host and your domain controller are syncing to the same source, that's not going to cause a time shift when you power that server on. So once you do that, you can just follow Microsoft's best practices for timekeeping. And one other important point, don't sync your vSphere host to your virtualized domain controller. You can see you can get into a chicken or the egg scenario there. So let's just look at a graphical representation of this with breathtaking PowerPoint animation. So here, I told you guys the jokes were the same. So PDC emulator, right? This is that PDC emulator that holds that FSMO role. I've got my ESXi host. They're all pointing to that same time source. Again, that can be external or internal. My domain controllers on the network are pointing to that domain controller, and my other domain joined members are pointing to that domain controller as well. So we've got VMware Tools time sync is disabled. This is the option we were talking about before. So I've got my virtual machine syncing to domain controllers that are syncing to an external time source, and my ESXi host syncing to that same external time source. If you want to read more about timekeeping, want to know more than you ever thought you would want to, read that bottom PDF. There's lots of great information in there.
There are common issues or common historical problems that make people shy away from virtualizing domain controllers. One common problem is the disk, the virtual disk, the caching or not caching of a virtual disk. If you're caching a write operation on a domain controller, if you have a power failure, the operations or the transactions that have not been committed to disk are lost. If you lose transactions in a database operation, you have problems. So there is the question of should we use battery backup for the storage or for the VMs or for the host running the VM so that we can commit the transaction before we have this full failure. Microsoft documented some of the problem associated with caching domain controller writes, and they have specific problems with it in the other hypervisor. I can tell you categorically here that vSphere does not perform any write cache. When you virtualize your domain controller, any VM in the vSphere infrastructure would not sit between the VM and the write operation and the disk. We pass it through. So there is no issue of FUA, first unit access, or write caching corruption on vSphere. The second one is AD, again, it has its own replication scheme. Okay, we are going to see in the next slide how the incident of USN Rollback impacts domain controllers, and I'm going to skip to that really quickly. What happens is if you, in a virtual infrastructure, if you revert a domain controller to a previous state, the domain controller will discard whatever has happened between the time you took the snapshot and the time you did the rollback. It would have lost history. It would have lost transaction. Snapshot and rollback are two of the good things in virtualization. It is why people use virtualization, why people started using virtualization originally. Test dev operation, you take snapshot, you roll back, you start all over again. If you do the same thing with domain controllers, you are asking for troubles, and you will see how that trouble manifests itself in an AD infrastructure. What you're going to see is the incident of USN rollback. USN rollback is problematic for AD. I will get into more detailed explanation of that scenario. Way back when? Before Windows 2012. People are afraid, legitimately, reasonably afraid of virtualizing domain controllers because it is very easy to right-click on that VM, take snapshot. Take the snapshot, keep the snapshot for a day, 2 days, 1 month, or whenever. Something happens, somebody panics and say, oh, we have snapshot, we can use that for recovery. They go in, they apply the snapshot, discard every transaction, and AD is host. It can impact the whole forest. Forest recovery is what you get into. Forest recovery is a very expensive undertaking. This is why people were always afraid of virtualizing domain controllers. Let me describe that real quickly. We mentioned invocation ID, we mentioned DSA, we mentioned USN. Every write operation, every operation on an object increments the USN. So let's take an example of two domain controllers in a domain. You have DC1 here and DC2 there. This DC1 has invocation ID of DC1A. Its current highest committed USN at this point is 100, just a random number. Both DC1 and DC2 are in sync. DC2 knows that the latest update vector from DC1 is at 100. All right? We create 10 more users. It's a new write operation. It increments the USN. Okay, now this DC says I have a changed USN, I need to replicate it. It takes the 110 and replicates it to DC2. DC2 will then update its update vector for DC1. Says, okay, I got transaction 110 from you, we are in sync. Last update sequence number was 110 at this state. We then go, we take a snapshot at 110. We created 10 more users, which increments the USN to 120. DC1 sends that to DC2. DC2 updates its vector to say, okay, I received 120 from you. Remember, we took snapshot at 110. We've since made more changes. Okay? Now we reverted the snapshot. We applied the snapshot to this VM, rolling it back to previous state. The previous state was when it was at 110. Are you following me? Now this C1 goes back, boots up, say, oh, 110, that's my last update. All right, I'm going to create 10 more users. 110 plus 10 equals 120. Okay, this USN is 120. I'm going to send it out to DC2. DC2 here, I have transactions for you. The update sequence number is 120. And DC2 is going to say, no, I've seen that before. Like 2 years ago. This is one of the major reasons why people don't virtualize domain control. It's simplicity with which you can roll back a DC to a previous state. And any legal person here, you can crap up your AD, is what I'm trying to say. All right. That was then. This is now. Microsoft saw this. Everybody's aware of this. Even though people were still virtualizing domain controllers, even though we put some safety measure into the hypervisor to prevent you from doing that, something like that didn't quite fix the problem. Microsoft came up with, okay, we're going to fix this problem. Everybody is virtualizing like our friend Matt just said. Why won't we let people virtualize domain controllers?
Oh, we're friends?
We're.
Okay, so Microsoft, I think, gets a lot of flack for some of their policies, but they're actually very virtualization friendly, and this is a great example. So in Windows Server 2012, Microsoft put something called the generation ID, the VM generation ID, which is a way for the domain controller or the virtual machine to actually become aware that it's virtualized. This is something that's only exposed to virtual machines. It's done so in a communication level from the hypervisor directly to the guest, does not leverage VMware tools, it's multi-hypervisor, works on theirs, works on vSphere. It's a way for that virtual machine to know I'm virtualized. That value is stored in your VMX file. So if you edit it and you look at VM Gen ID or Gen ID X, you'll see it there. You'll actually see it for every single Windows Server 2012 VM or Windows 8 VM, whether they're domain controllers or not, but only domain controllers care about the value. So that ID is tracked not only at the hypervisor level, but in the local Active Directory database of that domain controller. It's an attribute that's not replicated. It's unique specifically just to that domain controller. So anytime that VM generation ID changes, and I'll talk in a second about what causes that to change, that's when the domain controller safety features kick in. There's really two benefits to this Gen ID. The first is safety, which in my mind is the most important, but then there's additional functionality in cloning, allowing you to actually clone a domain controller, something you weren't able to do in the past. So just really quick, if I've got a domain controller or a virtual machine that's set to Windows Server 2012, I can look in my VMX and see that value there. I can edit it manually and see it there. See it right there. Or and then I can look inside the guest itself and see the value there. So there's some reasons why the Gen ID changes and some that do not. And I think a helpful way to think about it is anytime the virtual machine has sort of traveled through time, has changed its clock, that's something that's going to trigger the virtual machine to reset and have the Gen ID change. So rebooting the virtual machine or the vSphere host, that's not enough. But if I revert from a snapshot, either when the VM is on or off, or if I clone the VM, whether the VM is on or off, that's enough to trigger it. Hot cloning is not supported, so we're not really going to cover that, but that's an example of things that'll trigger it. Restoring a virtual machine from a backup, an image level backup, that's another common one that'll trigger this change, kick in these safety features we're going to talk about in a couple slides, and protect your domain controller from what Deji just described before with USN Rollback. So let's quickly talk about domain controller cloning, and then we'll go over the safety features.
Domain controller cloning. The VM generation ID, again, when a state of a domain controller changes or a VM changes, we track it, we surface it in the system, the operating system reads that value and says, okay, you've changed, and now we need to do something. That's where the safety and the VM generation ID functionality kicks in. The hypervisor is the one that changes the generation ID and reports it to Windows. DC cloning enables you to deploy domain controller very fast. If you were doing DC cloning in prior version to 2012, of course, you are going to have an exact clone of the same domain controller, and if you bring it up, there's going to be conflict, and bad things will happen. With generation ID, the Windows takes care of that conflict. There are specific guidelines that you have to follow, specific steps you have to follow to have a successful cloning of your domain controller. This is specified and dictated by Microsoft. It's not dictated by VMware. You prepare the domain controller, the reference domain controller in sequence. The first one is add the domain controller that you're going to clone, add it to a special AD group. The AD group is called Clonable Domain Controller Group. It's a security group. If a domain controller is not in that group, that domain controller cannot be cloned. That's your safety measure. If you put it in that group and then you prepare the domain controller for cloning, it will be successfully clonable. You check for non-clonable software. You create the DC cloning configuration file. You shut down the domain controller. It is very critical if you're going to clone a Windows 2012 domain controller in vSphere. You must shut down, in any hypervisor, you must shut down the domain controller. Microsoft does not support hot cloning of domain controllers, even with all the safety they put in there with generation ID. You clone it, and then you power on the new DC. When you power on the new DC, because now this is a clone, we've changed the generation ID, the VM would then evaluate the generation ID, and because it's changed, it will trigger some safeguard that Microsoft has put in there. The first thing it does, it discards its read pool. A domain controller that does not have a read pool cannot create objects. You can create any security object, any user object in AD if you don't have a read to assign to that object. The invocation ID of the domain controller is then reset automatically. The new VM then checks for the existence of this file that you created up here as part of your preparation. When it sees it, it then starts the cloning process. And the new DC is now promoted to a real DC. It gets its own new set of read pool. It gets its own new invocation ID. And it begins advertising itself as a real domain controller. Let's take a quick look at a demonstration of this. We have a DC02 here. And its generation ID right now is 001. And what we are going to do is we are going to prepare it because we want to clone it. We do the preparation. This is what the config process looks like. We clone it. Because we cloned it, the hypervisor gives it a new generation ID, different from the generation ID of the original. The VM doesn't know about that generation ID yet. We power on the VM.
Clicker's not working?
Yeah,
I'll be your clicker.
We power on the VM. The hypervisor then tells the VM what the generation ID is. The VM reads the config file on boot. It says that it has a config file. This is what I'm supposed to do. This is what I'm supposed to be. I'm supposed to be computer WK3 DC03. And VM generation ID and DC cloning operation starts happening. the VM becomes a new DC with a new generation ID, with a new invocation ID, with a new set of read pool.
Okay, so domain controller cloning is cool, but in my mind, this is the really important feature, and that is domain controller safety. This is shot, huh? Okay. So anytime I revert a virtual machine from a snapshot or restore it from a backup, you want to make sure that that domain controller can continue to function as a domain member in the environment. Otherwise, what was the point of doing it in the first place? So the gen ID is actually evaluated before the virtual machine even completely boots up and can start replicating with other domain controllers. So it happens really early on in the process. It can see if there's going to be a problem or not and has to take action. So similar to what we just described actually with cloning, it's really the same process. It boots up, or a new Active Directory update that replicates in causes that domain controller to quickly evaluate that gen ID. If it's different, it does the same thing that it did with cloning. It dumps the RID pool and it generates a new invocation ID for the local Active Directory database. So that allows it to do two things. The first is anyone that's made new changes since it boots up, it allows it to properly replicate those changes with other domain controllers, because we don't want to lose those changes. Those are valid. But then it also says, what about those changes I missed when I was sleeping, right? All the other domain controllers will say, here's what you missed, and allow you to replicate that back. So let's look at another example of that. One more real quick. If you don't clone the VM properly or don't prep it properly, you end up in this directory services restore mode jail, which we have a KB on to show you how to get out of. So we'll look at a similar example. Think back to Deji's example early on when he showed you what happened with USN Rollback. Think about that as we go through this process, and you'll see where it differs. So we've got a virtual machine. Gen ID is 1, invocation ID is A, and the USN is 101. So you can see that right here. So everything's good. I'll take a snapshot. Nothing has changed, right? The snapshot, taking the snapshot, doesn't cause the gen ID to refresh. It's just reverting. So everything is the same. I create a user. I've my USN's 101, invocation ID is A. Replicate over to DC2. DC2 says this is a valid transaction. I accept. Everything's good. This is just like the example before. Now I've reverted that snapshot. So now what happens? That is an action that causes the gen ID to refresh. And now that one is 02. So now my gen ID has changed. It's communicating with the ESXi host. So I have a new gen ID and I've got a new invocation ID. But I'm back to USN 101, right? Because I've reverted my snapshot. So now I'm going to create user number 2. Now if you remember on Deji's slides, here's where we got into trouble. We tried to replicate this and the other domain controller said, I'm not going to have any of this. But here, because it sees that even though the USN is the same and it knows it's seen it before, it sees that the invocation ID from that domain controller is different. And so it accepts that change. It says, I accept this. While you were sleeping, you also missed user 1, so I'm going to replicate this back. So in this scenario, this is where Deji's domain controller kind of got blacklisted and the other DC said, I'm not going to replicate anything to you. But because of the new safety features in 2012, now everybody's happy. If that song is now stuck in your head, you're welcome. It's been playing in my head for 2 weeks. Okay, so just because you can do this, does that mean you should? Are there any valid reasons why you would want to do this? The first is the most obvious one. Most of the image-based backup software that we use for virtual machines leverages snapshots to make sure we have a clean and consistent copy of the VMDK. So anytime you restore a backup of a domain controller, you're going to need this feature. The other is, let's say I need to install a piece of software on my domain controller. Maybe it's a backup agent, antivirus software, and you're not sure if it's going to cause a problem. You could take a snapshot, just like you would any other server, safely revert back if that software causes any trouble. But first of all, I think we all know that snapshots are not backups. A lot of times it's actually easier to just deploy a new server, promote that server to a domain controller, rather than trying to restore from a backup, unless you've got a catastrophic failure. It's usually easier just to restore individual objects like users or groups that have been deleted. But in general, this is a nice to have feature. It's nice to know that it's there. It's probably not something you're going to use frequently, but it's good to know that it's there.
Are you with me? You've seen how it was. You've seen how it is now. With VM generation ID, virtualizing domain controllers becomes a safer operation, safer than it used to be. There are things you need to do Again, we do not support, Microsoft does not support hot cloning a domain controller regardless of the VM generation ID and the safety. If you do, the clone will succeed. The resulting clone will not get into DSRM mode. However, due to some implementation thing, which I don't want to call a bug, in the generation ID and safety feature, that resulting DC that you hot clone will eventually pollute AD. So please, when you go and start implementing this on your Windows 2012 domain controllers, shut down the reference domain controllers. Remember that you told you. The reference DC ideally should not have the operation master roles. You could clone them. We do not recommend that you do, and you will not be able to clone the read master. Microsoft puts some block in there. If the DC is performing the read master operations role, you will not be able to clone it regardless of how much you try. You can clone the PDC emulator. We recommend that you don't because you want there to arbitrate the cloning operation. DNS is very critical. It must be reachable during a cloning operation. If it's not, that domain controller, the resulting domain controller, will end up in directory service restore mode, and you will need to go and perform some complex operation to recover from that. You may want to use the cloning operation to massively deploy domain controllers. Say you want to roll out a massive amount of Windows 2012 domain controllers for whatever reason, regardless of what my friend says. You can do that with this new feature. You take a reference domain controller, you prep it like we just described, you take the number or however many versions or copies of it you want to take in vSphere, and because you've prepared it, when you bring up all these new clones, VM generation ID will prep them to be new domain controllers. So you can massively deploy multiple domain controllers from one single reference domain controllers. If you have to do that, there are certain things you need to, certain operations you need to follow. One of them is that you should exclude the computer name, the clone computer name, from the.
Did I do something? Oops.
I'm sorry about my clicker. No clone computer name. And don't use static IP in the DC config file. What happens then is when the clone comes up, they won't have a name. There will be the name of the reference DC-CL-001-002-003, however many clones you want to perform. You cannot use one config file with a computer name to create multiple domain controllers because it always reads that domain controller DC name from the XML file. Don't turn on the reference DC if you're going to perform massive cloning. Once you power it off, once you configure it and you power it off, the XML file remains there, and when you clone it, the XML file will continue to work. If you bring it back up, Microsoft puts something in Windows that renames the XML file. So if you power it on and then try to clone it again, the XML file will not function. Whatever you clone from there will end up in DSRM mode. When you are cloning a domain controller in vSphere, do not check the box to do guest customization. Guest customization interferes with the DC cloning operation. Remember, don't check that box.
Okay, we're real short on time. I'm going to go very, very quick on this just for what we talked about earlier. You need to have vSphere 5 update 2 or better. You need to have Windows Server 2012 exposed as the virtual machine, the guest operating system, otherwise you're not going to get it. Leave that clonable domain controller's AD group empty. We want to make sure we have proper, we don't want to have accidental cloning, but we also want to make sure we have proper role-based access control where the vSphere administrator doesn't have rights to do this. The Active Directory administrator puts the server in that group. The vSphere administrator does the cloning, so you have proper separation of functions. Make sure that all the software that's in there, backup agents, things like that, are actually supported and safe for cloning. VMware Tools is an obvious one. If you're using Windows backup on that virtual machine, after you do the clone, delete those backups and start over. You're not going to restore a backup from a clone onto a new server. And then again, if you're going to use templates, think about the tombstone, the fact that that template will only be good for some period of time. Here's the KB if you ever get stuck in DSRM jail. Just going quickly, we have a couple slides at the end here. Just key takeaways. We've already seen how awesome Windows Server 2012 is, right? So it's much safer and easier to deploy your domain controllers in vSphere if you use Windows Server 2012. It's fully supported. It's an easier application to virtualize. So don't have any fear there. Your best practices for physical are the same as virtual. And again, if you're thinking about doing this, bring Windows Server 2012 to the party. Windows Server 2003 is end of life, I'm sure we all know. 2008 is probably not that far behind it. So if you're thinking about doing something like this, now's the time to bring Windows Server 2012 to the party.
Okay. We have some conceptual use cases, but we want to give room for questions. If you have any question, please, the microphones are here. We can take them, and then we can go into more presentations.
Just to be in a 2012 schema, or just a 2012 machine with a 2008 schema?
You can do it in a mixed forest or a mixed domain. Okay. You can only do it on DC 2012 DCs. Yeah.
So it's a good question. So the question is does the Gen ID take into effect on a physical domain controller as well? It's not even present on a physical server. It's something that's exposed only by the hypervisor.
So in the past, to combat the time drift on a domain controller that's PDC emulator and has been virtualized, I've increased the sync period in the registry of that domain controller that holds PDC emulator. Is that?
Well, yeah, whatever you do right now in physical, that's what you do in virtual. And whatever you do to keep the time in sync, as long as you're not syncing with the ESX host, you're good. So you can optimize the time sync or frequency on the domain controller. That's a good operation.
Okay. Thank you, everyone, by the way. I know we still have a couple more questions, but thank you.
Please ask your question.
All of the best practices that you've been presenting, are they also applicable to read-only domain controllers, or are there special considerations?
Special situation in the sense that you cannot clone a read-only domain controller, and you cannot get a clone that becomes a read-only domain controller. And everything else is the same. We place a specific emphasis on the feasible role orders and the timekeeping. There's nothing special about read-only domain controller. It's not even in consideration for generation ID.
Okay. Thank you.
You're welcome. Yeah, I'll take a copy.
Maybe you guys mentioned this and I missed it. If doing a snapshot of a domain controller, can you do it while it's running hot, or is a best practice to shut it down?
Snapshot?
Right.
We don't recommend you do snapshot.
I think what you're asking is, can I do it hot? Yes. The feature will protect you either way. Is that what you're asking?
Right.
Yes, the Gen ID, the safety features will protect you either way, whether it's cold or hot.
Right, whether it's being done as part of your backup procedures or...
Oh, the backup?
Yes, doesn't matter. You're protected in either case.
Okay, thanks.
Thank you. Do we have questions over? Do we have a mic over there? I don't know. Go ahead.
Yes.
We got 2 minutes, then they're going to play the music and kick us out, but we can take this outside.
Okay.
Yeah, is this working? Okay, good.
Yep.
So the default, of course, in 5.5 for the adapter, for network adapter for 2012 is usually the E1000E. And I noticed that you recommend the VMX-Net 3, but I've had Windows admins come to me and ask me to switch it to the E1000E because they were having some weird network anomaly. I'm just wondering if that had come across and whether that's anything you'd seen and whether you would still encourage VMX-Net 3, because when we switch it back to the E1000E, snap your fingers, problems are gone.
That was only with Windows Server 2012 domain controllers, or just in general?
Only with Server 2012. In fact, we have an MIS, ILM, a FIM system as well, but they noticed a performance degradation. We switched to the E1000E. That went away. I'm not worried about performance being that significant because DCs aren't doing quite that much, but I am concerned about reliability, that it comes back up sometime, and you want your DCs to be reliable. Had you seen anything along those lines with any Server 2012 or anything along?
So I can talk to you after this.
Very good.
But we do, for the benefit of everybody listening, we recommend VMX-Net 3. If you're having issues with it, we need to resolve it. E1000E or E1000, we don't recommend. But I'll talk to you.
Go ahead.
Yeah, gentlemen.
Prior to 2012, the restoring snapshots is completely not recommended, right? The native restoring through Active Directory backups is.
If you're on
the way to go.
if you're on 2012 and you restore a snapshot, VM generation ID.
No, prior like 2008.
No, we don't recommend that. We don't support it. We don't recommend it. And if you have 2008 domain controllers right now, you could mark the disk as persistent, and you won't be able to take a snapshot of that VM anymore. We recommend that you do not take snapshot of anything lower than 2012.
Okay.
Okay.
Any other questions over here?
Do you typically reserve all the resources?
All right, we'll take the questions
take it
outside.
outside,
Thanks,
please.
everybody.
Thank you.